Hello everyone, I'm Poonam Sharma. Welcome you all another session of Metals and Non-Metals chapter. It is very important chapter of chemistry, and in previous class I have started with this chapter. In that class I have discussed about metals, their physical properties, and we have already discussed some exceptions of metals like sodium, potassium. So we have discussed their physical properties in previous class. So I hope you have revised whatever has been taught by me in previous class. Now in today's class, I'll take chemical properties of metals. Although I have explained one chemical property of metal, which is when metal react with oxygen, it forms oxides. Now, second property of metal is when metal react with water, they form hydroxide. So when they react with oxygen, they form oxides, and when metals react with water, they form hydroxide plus hydrogen gas is liberated. So let's look at the examples of metals when they react with water, how the reaction takes place. First example is sodium. As you know, sodium and potassium, they are highly reactive metals. So they react vigorously with water. So what will happen if sodium metal reacts with water? Look here, when sodium reacts with water, it results in the formation of sodium hydroxide and hydrogen gas is liberated. So it results in the formation of sodium hydroxide, which is NaOH. And similarly, if you will take an example of potassium, I'll write this reaction here. If potassium reacts with water, it results in the formation of potassium hydroxide and hydrogen gases liberated in this case also. And sodium and potassium, this is sodium and this is potassium. These two are highly reactive metals. That's why we always keep them in kerosene oil. I have given 2 or 3 questions as a homework to you. I hope you have done those questions. So I ask you why we keep sodium and potassium in kerosene oil and not this calcium, sorry, not lithium. And the answer is because sodium and potassium, they are highly reactive metal. That's why we store them in kerosene oil. But we are not storing this lithium, although it is also very reactive metal, because it is less denser than kerosene oil and it starts floating on it. Okay. So when potassium and sodium reacts with water, they form sodium hydroxide and hydrogen gases liberated. Let's look at the example of other metals. Next is calcium. It is very important reaction. When calcium reacts with water, it also liberates hydrogen gas and it results in the formation of calcium hydroxide. And this calcium hydroxide, which is formed, see this calcium, it also floats over water. And due to this, what will happen? The bubbles of this hydrogen gas stick on this calcium. Yes. These bubbles of hydrogen gas sticks on the surface of the water. So when calcium reacts with metal, water, it results in the formation of calcium hydroxide and hydrogen gas is liberated. As you can see here, when calcium reacts with water, it results in the formation of calcium hydroxide and hydrogen gas is liberated. So this hydrogen gas, as you know, we have done test of hydrogen gas in previous chapter also. Wherever there is an evolution of hydrogen gas, bubbles are produced. So when this hydrogen gas is liberated, bubbles are produced and these bubbles start sticking on the water surface. Okay, so this is what happens when calcium reacts with water and it starts floating. Then reaction of magnesium metal. When magnesium reacts with water, It reacts with water very slowly and form magnesium hydroxide. Again, hydrogen gas is liberated. Students, whenever any metal react with water, result is always liberation of hydrogen gas and hydroxide is formed. Although these hydroxides are of different kinds, depend on the type of the metals we are taking. If we are taking calcium, it becomes calcium hydroxide. If we are taking sodium, it becomes sodium hydroxide. If we are taking potassium, it becomes potassium hydroxide. And in all the cases, hydrogen gas is liberated. But in case of calcium, the hydrogen gas which is liberated, it sticks to the water molecules. As a result, the calcium starts floating over the water. Now we are doing reaction of magnesium and water. So it results in the formation of magnesium hydroxide, and again hydrogen gas is liberated here. Then we have this magnesium when reacts with steam, because the temperature of steam is more than that of the water. So if this magnesium reacts with steam, it results in the formation of magnesium oxide and hydrogen gases evolve. And this reaction is very fast. It is rapid reaction. But this is slow reaction. So when magnesium reacts with this water, it is a slow reaction. But when magnesium metal reacts with steam, or we are passing steam over the magnesium metal, reaction becomes very fast and it results in the formation of magnesium oxide instead of magnesium hydroxide, plus hydrogen gas is liberated. So this is also very important reaction. Then we have reaction of aluminium metal with water. So when aluminium metal reacts with water, this reaction is very slow, and when steam is passed over it, the reaction becomes fast. Okay. I think some echo is there. So when this aluminium metal reacts with water, it results in the formation of aluminium oxide. When it reacts with, when we are passing steam over it. So this results in the formation of aluminium oxide. Similarly with that of the magnesium. So when we are passing steam over magnesium, it results in the formation of magnesium oxide. And when aluminium reacts with steam, or we are passing steam over aluminium, it results in the formation of aluminium oxide, plus hydrogen gas is liberated. Now next is when zinc reacts with water. When zinc reacts with water, it results in the formation of zinc oxide. Again, this zinc and iron, they will not react with normal cold water, where they react with hot water, or they will react with steam. So when they react with steam, they also results in the formation of zinc oxide, and hydrogen gas is liberated in both the cases, as you can see here. So aluminium, zinc and iron, they'll show very slow reaction with cold water, and that's why we need steam for this reaction. So when this reaction takes place between aluminium, zinc and iron, steam is passed over it, and all results in the formation of oxides instead of hydroxides. So remember these exceptions. Otherwise, other metals, they react with water and they result in the formation of hydroxide. But aluminium, zinc and iron, they will not react with cold water. So we need steam for the reaction. And when steam is passes over it, It results in the formation of oxides and hydrogen gas is liberated. Okay, now let's take an example of calcium, which I've already explained to you. Calcium starts floating over water. When it reacts with water, it keeps floating. And the reason behind is this calcium, because when the hydrogen gas which is liberated during the reaction, it starts sticking on the water. And as a result, calcium gets, start floating on it. And the reaction which takes place is calcium plus water, calcium hydroxide, and hydrogen gas is liberated. So these are, student, extremely important reactions. Now write down in the comment box what will happen if zinc reacts with cold water, or what will happen if aluminium reacts with steam. Name the elements which react with steam to produce oxides. Okay, write in the comment box, name the elements which produces oxides when react with steam. Then apart from those metals, there are other metals like lead, copper, silver, gold. They do not react with steam because they are less reactive metal and they do not react with steam, and this rate of reactivity is like this. Potassium is the most reactive one, and this is gold is a less reactive one. So this is how they are reacting with water, and that's why silver, gold, they not react with water, and we can use them in making ornaments due to their less reactive nature. But if we are talking about potassium, sodium, calcium, they are highly reactive. Magnesium, this is aluminium. Magnesium, aluminium, zinc, they are less reactive, so they'll react with steam. They are highly reactive. And they'll not react. Lead, copper, this is also, these are less reactive. They react with steam. So these are less reactive, these are more reactive, and they'll not react. This is how we'll place them in a reactivity series according to their rate of reaction. Then we have reaction of metals with dilute acid. When metals react with acid, they result in the formation of salt and hydrogen gas is liberated. Now look at the examples of such kind of metals when they react with dilute acids. Sodium being highly reactive, it easily reacts with hydrochloric acid, dilute hydrochloric acid, which is considered to be a very good acid. Now, when sodium reacts with hydrochloric acid, it can easily displace hydrogen from this acid. Look here, when sodium reacts with this hydrochloric acid, it displaces this hydrogen and takes its place. So it combines with this chlorine and it becomes sodium chloride, and this hydrogen gas is liberated. Now next is reaction of magnesium metal with dilute hydrochloric acid. See, when magnesium reacts with acid, again being more reactive than hydrogen, there's a reactivity series, and in that reactivity series, the metals which are placed above hydrogen, they are more reactive, so they can easily displace hydrogen. The magnesium being more reactive, it can easily displace hydrogen from hydrochloric acid and takes its place and combine itself with this chlorine, and it becomes magnesium chloride, and hydrogen gases evolve. The next reaction is reaction of zinc with dilute sulfuric acid. So when zinc reacts with dilute sulfuric acid, then zinc takes the place of hydrogen and it makes zinc sulfate and hydrogen gas is liberated. So now you can see when metals react with acids, they result in the formation of salt and hydrogen gas is liberated. And this zinc reacts slowly with hydrochloric acid, but it rarely reacts with sulfuric acid. And hydrogen gas, which is evolved when metal is treated with any acid, but when metals react with nitric acid, which is HNO3. See, when metals react with HNO3, which is nitric acid, hydrogen gas does not evolve. As you can see in previous example, when we have taken hydrochloric acid or sulfuric acid, in all the acid there is a liberation of hydrogen gas. But when metals react with nitric acid, no hydrogen gas is liberated. And the reason is the hydrogen, this nitric acid itself is a strong oxidizing agent. And it oxidizes the hydrogen which is liberated when the reaction takes place into water and itself gets reduced. That's the reason why hydrogen gas will not liberate when the metals react with nitric acid. It is very important question. It's 2-mark question. It's 2-mark question. Why hydrogen gas does not liberate when metals react with nitric acid? And the answer is nitric acid being an oxidizing agent, being a strong oxidizing agent, it oxidizes the hydrogen and into water and itself gets reduced into oxides of nitrous oxide, nitric acid or nitrogen dioxide. So that's the reason why hydrogen gas is not liberated when metals react with it. Now copper, gold, silver are known as noble metals. They do not react with water or dilute acids because they are less reactive in nature. They will not show reaction with the water. Okay, that's why we call them noble metals. And they will not show reaction with dilute acids also. And the order of reactivity of metal is shown here. First is potassium, then sodium, then calcium, magnesium, aluminium, zinc, iron, copper, mercury, silver, and here we have gold. So this is the sequence of the metals. Now if metals react with solution of other metal salts, then what will happen? See, when reaction takes place between metal and other metal salt, displacement reaction takes place. The most reactive metal displaces the less reactive one and it results in the formation of salt. For example, if metal A reacts with salt of metal B, it results in the formation of salt of metal A and metal B. Let's look at the examples. Iron and copper sulfate. So when iron reacts with copper sulfate, iron being more reactive than copper, it displaces copper from its salt solution and forms iron sulfate and copper is left behind. So it means this is known as displacement reaction because iron displaces copper from its salt solution. Although it results in the formation of salt only. Then aluminium and zinc, they can easily displace copper from the solution of copper sulfate because aluminium and zinc, they both are more reactive than copper. So look at the reaction. Aluminium when react with copper sulfate, it displaces this copper and it becomes aluminium sulfate and copper is left behind. Another reaction of zinc with copper sulfate, it displaces its copper and it becomes zinc sulfate and copper is left behind. So in all these examples, as you can see, iron, aluminium and zinc. Being more reactive than copper, they can easily displace. And this kind of reaction is known as displacement reaction. We have already done this displacement reaction in first chapter, if you remember. So in displacement reaction, more reactive displaces the less reactive one. Now when copper is dipped in the solution of silver nitrate, it can easily displace silver. Look at the reaction. It is extremely important reaction. What will happen if copper reacts with a silver nitrate? Being more reactive than silver, it can easily displaces it. Look here. So when copper reacts with silver nitrate, it results in the formation of copper nitrate and silver is left behind. There is an activity. You can take 2 test tubes. And in this test tube, you can take silver nitrate plus copper. And in this test tube, you'll take copper sulfate plus silver. Okay. Now, what will you do? In test tube, this is test tube A and this is test tube B. In test tube A, we have taken silver nitrate. Then we add wire or a piece of copper into it. You'll observe that after a certain period of time, the color of this silver nitrate turns blue. It turns blue in color and the color of copper is also changed. The color of silver comes on this copper. The color, it has some silver color over it. Okay. So the color of this silver nitrate turns blue. So this shows that copper can easily displace silver because earlier the color of silver nitrate was different and now it is blue in color due to the presence of this copper. But in test tube B, in which we have taken copper sulfate and we add silver into it, no reaction takes place. The color of this copper sulfate remains as it is. There is no reaction because silver is less reactive than copper, so it will not displace it. This is extremely important reaction. Now another such kind of reaction is when gold is dipped in the solution of copper nitrate. Gold is less reactive than copper, so no reaction takes place. But if we take aluminium nitrate and copper, so here copper is less reactive than aluminium, so copper will also not displace it. Okay, so from these examples, it is very much clear that the metals which are less reactive, they cannot displace the more reactive one. And this is the reactivity series in which we have placed metals according to their rate of reaction. So the best way to learn is, please stop calling me a careless zebra. Instead, try learning how copper saves food. So potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, tin, lead. So they are placed above hydrogen. It means all these metals can easily displace hydrogen from dilute acids. But these cannot displace hydrogen. And these are more reactive metals, so they can displace one another. Like if the reaction takes place between magnesium and zinc. Zinc cannot displace magnesium, but magnesium can displace zinc because magnesium is more reactive than zinc. So more reactive metals can easily displace the less reactive one. And if the reaction takes place between iron and silver, no reaction takes place because it cannot displace it. And you know, we are talking about gold. Gold is the least reactive metal. Gold is considered to be least reactive one. That's why we use it in making ornaments. And there is one more term which is aqua regia. Although gold does not react with acids. So aqua regia, it contains 3:1, which is 3 parts of hydrochloric acid plus 1 part of nitric acid, HNO3. So this is known as aqua regia, and this aqua regia used by goldsmith when they want to clean gold ornaments. This is aqua regia, which is a combination of 3:1 ratio, 3 HCl and 1 HNO3. Although gold does not react with acids, but sometimes it loses its shine. So to regain its shine, it reacts with this aqua regia. And when we dip this gold into aqua regia, it cleans the outer layer of the gold and makes and regain its shine. Then we have certain important questions according to exam point of view. Let's discuss those questions. Zinc oxide is considered an amphoteric oxide. Children, in previous class I have given one question to you. Can name any one amphoteric oxide. So zinc oxide is considered an amphoteric oxide because it shows both acidic and basic behavior. So if any metal or oxide of that metal behaves like acidic and basic in nature, that is known as amphoteric oxide. And why metals conduct electricity? Metals have free electrons in them. Due to the presence of those free electrons, for example, sodium, potassium, then iron, they have free electrons. So due to the presence of these free electrons, they can conduct electricity through them. And if you remember, one more point I cleared when I was explaining this electrical conductivity. They have positive charges also. They have positive charges also, and electrons are just freely movable. So when we increase temperature, due to increase in the temperature, these positive charged particles, they start vibrating. And when they start vibrating, they act like an obstacle or hindrance which does not allow these electrons to move. And as a result, the rate of electrical conductivity decreases. Okay. So why metals conduct electricity? Due to the presence of these free electrons only. Now next is, what property of hydrogen is observed in the following experiment? Balloon filled with hydrogen floats. When we fill hydrogen in a balloon, it starts floating. See, first and then pop sound is heard when a burning splint is introduced at the mouth of hydrogen filled jar. So whenever there is liberation of hydrogen gas, so we always take any burning matchstick and we hear this pop sound. The next is, when black cupric oxide is heated in a stream of hydrogen, reddish color is obtained. So what property is this? It shows that hydrogen gas is light in weight. When we fill hydrogen gas in balloon, it starts floating. It shows that hydrogen gas being lighter in weight, it makes the balloon light, and as a result, balloon keeps floating on the water. And the second is, this is the combustible property of hydrogen. It means it is a combustible property of hydrogen. So hydrogen burns with oxygen at the mouth of the hydrogen filled jar. So when hydrogen gas is liberated and we bring any matchstick, burning matchstick near it, that pop sound indicate the presence of hydrogen gas, which acts like a combustible gas. So when it combines with oxygen. And third one is, so when black cupric oxide is heated in a stream of hydrogen, reddish color is obtained. So when hydrogen has reducing property, so it reduces that black cupric color of copper to red copper metal. So these properties of hydrogen gas are observed when the following experiment take place. So I hope this question is clear to you. And the next is, sodium, potassium and calcium metals form hydrides by combination with hydrogen gas, but most other metals do not. And the answer is, metals like sodium, potassium and calcium, they can force the hydrogen atoms to accept electrons given by them. They are highly reactive metals and they lose electrons. As I told you, metals are electropositive and they lose electrons. So when they are losing electrons, they allow that, or they force that hydrogen atom to combine with them and form hydrides, which other metals do not. Next is, aluminium easily combines with oxygen, but still it can be used for making kitchen utensils. See, aluminium reacts with oxygen and it forms an aluminium oxide layer over it. So due to this, it does not allow the rest of the aluminium to get corroded. So that's the reason why we use aluminium in making utensil, although it combines with oxygen and form oxide, because it forms aluminium oxide. Similarly with magnesium also. When magnesium reacts with oxygen, it forms magnesium oxide. And that's the reason we always clean this magnesium ribbon before burning it, so that we remove that layer of magnesium oxide and it starts burning. So these are the reasoning questions which can come on the basis of the topics which I have covered so far. Then we have non-metals. In non-metals, we'll study about their physical properties, chemical properties, and their reactions, which includes reaction of non-metals with different substances. Now, there are different non-metals present around us, like carbon, sulfur, then oxygen, nitrogen, chlorine. They all are non-metals. And non-metals are known as electronegative elements because they have negative ions. Non-metals accept electrons. That's why we call them electronegative elements. For example, oxygen. Its atomic number is 8 and its electronic configuration is 2,6. So it will not lose 6 electrons. It will take 2 electrons to make it itself stable in nature. So it will take 2 electrons, and here it is accepting electrons. That's why it is electronegative in nature. Or let's take an example of chlorine. Atomic number is 17 and its electronic configuration is 287. So it also takes 1 electron. So they are accepting electrons. So when they are accepting electrons, they attain negative ions on them, or we can represent them by O2 minus because it is accepting 2 electrons. Chlorine represents by minus, it means only 1, so it is accepting 1 electron. So we can represent them by these formulas. Okay, these are the ions form, and that's why they are known as electronegative elements. Now, what are the physical properties of non-metals? The properties of non-metals are entirely opposite to those of metals. Non-metals are quite soft. They are not hard as the metals are. They are very soft and they can easily break. They can be brittle. They are except diamond. Diamond is the only exception in non-metals, which is an allotrope of carbon. We'll study about detail. Uh, we'll study in detail about carbon in carbon compound chapter. So carbon exists in two forms in nature, in diamond form and in graphite. So these are the two allotropes of carbon. These are two allotropes of carbon, and diamond considered to be the hardest substance known. Apart from diamond, all other non-metals are very soft, they are brittle, we can easily break them. Then we are talking about state. Non-metals exist in solid state, liquid state, and in gaseous state. Like oxygen, nitrogen, it exists in gaseous state. And if we are talking about luster, it means whether they have shine or not. Non-metals are not shiny. They do not have any shine. They are dull in appearance. Except diamond and iodine, they are lustrous in nature, and these are the exception in case of non-metals. So you need to learn these exceptions because the question can come on these exceptions, and generally questions can come in 1 mark. Name the non-metals which are lustrous or which have shiny appearance, and the answer is diamond and iodine. Okay. Then next is sonority. Sonority means sound. So when non-metals hit with any hard object, they will not produce any sound. Conduction, non-metals are not bad conductors of heat and electricity due to the absence of free electrons. They do not have any free electrons except carbon. And the allotrope of carbon, this graphite, it is considered to be a good conductor. We use in dry cells. We use in machineries as a lubricant also. So graphite is considered to be a good conductor of heat and electricity. Okay. Then malleability and ductility. We cannot convert non-metals into sheets and wires. They are so brittle, we cannot convert them. If we try to convert them into sheets and wire, they'll break very easily. So they are non-malleable and non-ductile in nature. And non-metals generally have very low melting and boiling point except diamond, which has very high melting and boiling point. Then if we are talking about densities, non-metals have low density, again except diamond, which is quite very dense. It has high density. Then we have next property is color. Non-metals are in many colors. They exist in many colors in nature. So these are the physical properties of non-metals. And these are the exceptions of non-metals. Carbon in the form of graphite, it is the best conductor of electricity. Iodine, lustrous in nature along with diamond. Carbon is extremely hard in the form of diamond, and diamond has high melting and boiling. So these are the exceptions in case of non-metals. Go through these exceptions and the physical properties of non-metals and chemical properties which I have discussed with you. Chemical properties of metals and physical properties of non-metals. So in next class, I'll discuss chemical properties of non-metals with you. So till then, take care and goodbye. So go through each and every topic carefully. And don't forget to learn all the exceptions. Because question can come on these exceptions. Generally, it comes in 1 mark. These are the exceptions which we have done in case of non-metals. So I am giving you one question as a homework. Name the non-metal which is a good conductor of electricity. So write the answer in comment box and revise these physical properties of non-metals. These are the physical properties which I have discussed. And these questions also I have discussed with you. And these are the difference between metals and non-metals on the basis of their properties. Like metals are solid, non-metals are solid, liquid and gaseous. So metals are heavy in weight, non-metals are light in weight. Metals are good conductor of electricity and heat, non-metals are not. Metals have luster, non-metals do not have luster. And when you are writing these points, write down exceptions. Okay. Then metals have high melting and boiling point. Non-metals do not have. They have low melting and boiling point. And metals produce sound. They are sonorous. Non-metals are non-sonorous. And metals are malleable or ductile. We can easily convert them into sheets and wire. And non-metals are non-ductile or non-malleable. So these you can easily. These are the difference between metals and non-metals on the basis of their physical properties. Only on the basis of their physical properties.